Hello, my name is Chase, and my presentation today is on Fluorouracil, or known as 5-FU. So just to begin things with, 5-FU is a chemotherapy drug that is used to treat different types of cancer, including colon, breast, and digestive tract cancers. It is also metabolized by cells into three analogs, and these names are fluorodeoxyuridine monophosphate, or known as FDUMP, fluorodeoxyuridine triphosphate, or FDUTP, and fluoridine triphosphate, which is FUTP. The active metabolite in FDUMP inhibits the enzyme thymidylate synthase, or also known as TS, which is a crucial enzyme in DNA synthesis. So this picture on my right side is kind of mainly just the mechanisms of TS inhibition by 5-FU. So kind of wanted to highlight just the overalls of it, so you kind of see where the F DUMP fits in with the TS, and then also how it just kind of leads to either DNA replication and repair or DNA damage. Continuing from here, we're going to talk about fluorouracil metabolism. And so then again, 5-FU is converted into three different analogs, as we already went over. The F-dump is one of the metabolites that binds and inhibits the enzyme TS, which is essential for DNA synthesis. FUTP is another metabolite and is incorporated into RNA instead of uridine, leading to inhibition of protein synthesis. Kind of just over here again on this diagram to my left, just showing where everything fits in. Again, in this picture is different from the last one, mainly because of how the FU can lead from the FUMP to the FUDP to the FUTP, which causes the RNA damage. And then it also shows how it leads to the DNA damage, which I thought was pretty interesting. So the next thing I kind of want to cover is the inhibition of RNA synthesis. So fluorouracil works by interfering with the incorporation of uridine into RNA molecules, as we've discussed. Specifically, the active metabolite FUTP is incorporated into RNA in place of the uridine. So once FUTP is incorporated into the RNA, it causes distortion and destabilization of the RNA structure, which prevents the RNA molecule from being used in protein synthesis, leading to inhibition of cell growth and division. One of the last things I wanted to kind of talk about was the mechanism of inhibition. So F5U is structurally similar to uridine, but has a fluorine atom in place of a hydrogen atom. The fluorine atom in FUTP causes steric hindrance in the RNA molecule, which leads it to distortion and destabilization of the RNA structure. This destabilization prevents the RNA molecule from being used in protein synthesis, which is ultimately leading to the inhibition of cell growth and division. The inhibition of RNA synthesis by 5-FU is specific to cancer cells due to their high rates of replication and altered RNA metabolism. So in this picture to my right of me, it's mainly just showing the, I want to focus mainly on part B. It's kind of showing the characteristics and signaling pathways of CSC contributing to 5-FU. So as you can kind of just see over here, the CSC resistances kind of what they lead to. So like if I go this way, it's talking about my MDR transporters, and then from there it's my drug transporters, and talks about the proteins. Another little interesting pick. So mainly to summarize all of my points, I mainly just chose four to really take away from it, and that is that Fluorouracil is an effective chemotherapy drug that works by inhibiting RNA synthesis and cell growth and division. The active metabolite F-dump inhibits the enzyme TS, while FUTP causes distortion and destabilization of RNA structures, leading to inhibition of protein synthesis. And although Fluorouracil has proven to be highly effective in treating various forms of cancer, it can also have side effects such as gastrointestinal problems, skin reactions, and bone marrow suppression. And patients receiving Fluorouracil should be monitored closely, mainly for these side effects, and should report any symptoms to their healthcare provider or doctor instantly. And these are my references used. Thank you all for listening.